Hello friends, in this video we are going to see example on classification of system in terms of impulse response. Consider a system given with impulse response h of t equal to 3 into delta t. So first we need to classify the system whether it is static or dynamic. So for the condition of static system, we know that the impulse response h of t should be c into delta t. So if you compare the given impulse response, which is 3 into delta t, with this standard equation h of t equal to c into delta t, so the impulse response given satisfies this criteria, hence the system is static. Now the second classification is causal and non-causal. So again, the condition for a causal system is given as h of t should be equal to 0 for t less than 0. So for the given equation, if we look at it is 3 into delta t, and if we write the equation for delta t function, it is equal to 1 for t equal to 0 and 0 for t not equal to 0. So this impulse function doesn't have any value for t less than 0. Therefore, it satisfies the equation for causality. Hence, system is causal. Now, the next classification is for stability, and for a system to be stable, we have the condition that integration from minus infinity to plus infinity h of tau d tau should be less than infinity. So if we substitute the values of given h of t in this integration, so it becomes 3 into delta t. Now it becomes delta tau d tau. So if we evaluate this equation, we get now this impulse function has value only at 1. So this can be represented as 3 into integration of delta t delta tau d tau. Now this integration has only delta tau function, which is impulse function, and it exists only at single point, which is at origin. Therefore this integration is evaluated at as 3, and this delta tau exists only at 0, so its value is 1. So if you represent it in a proper way, it will be simply delta t exists only at origin, hence this integration gets cancelled out and its value is 1 at origin, therefore it will be 1. So this integration leads to a constant value 3, which is less than infinity, hence this system is stable. So for this given system with impulse response 3 into delta t, this system is static, causal and stable. So let us see one more example. So let us say we have a second system whose impulse response h of t is given as u of t plus 2. Now we need to classify this system as causal. First is static and dynamic. So for static system, again we have the condition that the impulse response should be represented as c into delta t. But as we know, this impulse response given is the unit step signal, and the relationship between unit step and impulse function is that delta t is derivative of unit step, or if we do it in a reverse way, unit step signal can be obtained from impulse response by taking its integration. Therefore this u of t plus 2 cannot be represented as c into delta t, hence given system is dynamic. So you need to mention the reason also, because here u of t plus 2 cannot be represented as c into delta of t. Now the next classification is for causal system. The condition for causality is h of t is equal to 0 for t less than 0. From the given equation u of t plus 2, so if we draw the diagram for this u of t plus 2, here the shift is plus 2, hence this unit step signal starts at minus 2 and approaches towards positive infinity. So in the equation form we can write it as u of t equal to 1 for t greater than or equal to minus 2 and 0 for t less than minus 2. So here if you look at the condition for causality, it is h of t should be 0 for all the values of t equal to t less than 0. But here for this u of t plus 2, the values exist for t less than 0, that is from minus 2 to 0. Hence system is non-causal. Now the third classification is for stability. So a system is said to be stable if we integrate the given function h of tau d tau and its value should be less than infinity. So if we integrate the given impulse response from minus infinity to plus infinity u of t plus 2, now t becomes tau, so it should be represented in terms of tau d tau. Now u of tau plus 2 starts at minus 2, so these limits are going to change from minus 2 to infinity, and the value of u of t plus tau, tau plus 2 becomes 1 d tau. So it will be tau with the limits minus 2 to infinity. So here straight away we get the answer as infinity, therefore system is unstable. So this is how we can classify the system with the given impulse response as dynamic, non-causal and unstable.